Okay, here's a couple questions where first one is a question where you have to determine how much money you have after a certain amount of time. So it says it's appreciated, so it means you're making money off of your money, so you're making interest. So here's the formula for a compound interest question. If they say it's compounded continually, then you can use this other formula. What is it? Uh, P of t equals P0 e to the kt. You can use that one only if it's compounded continually. Okay, but if it's compounded semi-annually, annually, quarterly, whatever, anything other than continually, you want to use this formula. So they say you've got 14,000 initially, that's a principal. So 14,000 times 1 plus interest rate is 10%, so that's 0.10. Divided by n is the number of compounding periods. In this case, it's semi-annual, so that's twice a year. So I divide that by 2. Raised to the n is the same as this n, so it'd be 2 times. How many years? 3 years. There we go. So amount is equal to 14,000 times 1 plus 0.10 over 2 to the 2 times 3. One thing maybe, you could put all that in your calculator, and I'll try that in a second. But you could divide this, so 0.10 divided 2 is 0.05, and 1 plus that is 1.05, and then 2 times 3 is 6. It might be easier to put it in your calculator that way. Let me see, oops, let me see if I can do that on my calculator. Okay, that doesn't look like a calculator. Sorry, calculator. Here we go. So I'm just going to go 14,000 times 1.06 to the 6th equals, about that, 19,859. Hopefully that's correct. What was it, 19,859. 19,859. Okay, I might have, on this calculator, I might have done something wrong, but let me just check that. So 1.06 to the, where's my to the button? Oh, there we go. To the 6th equals times 14, oops, 1,000. Yeah, that's right, that's right. Okay, hopefully that helps with that question. Now here's a couple other questions where you have to draw some graphs. So here they say the graph of function and its inverse. One thing that we know about graphing and its inverse is that those two things, they will cross, or not cross, but they reflect over this line here. And this line is just y equals x. And it crosses, or it doesn't cross, but it's y equals x. I'm just trying to get it fairly close. Maybe down more this way. Up just a touch, right in there somewhere. Okay, so one graph, whatever I see on this side is going to be reflected on this side of that line. So what I can do is get some points. So I have y equals log base 2 of x. So we plug some numbers in for x. So say I plug in a 1. So x and y. Plug in a 1. To what power must you raise 2 to get a 1? That'd be 0. So that's that. Put a 2 in. So to what exponent is 2 raised to get 2? That would be 1. I could put a 4 in for x. So put a 4 in there. Log base 2 of 4 is 2. And I could keep going like that. The next one I'd get is 8. And that would be 3. I'm figuring these things out just by plugging in, like I'll do this last one. Log base 2 of 8. So I'm using base 2 numbers here so that I can come up with an actual number over on this side. So, and if you do this on your calculator, you'd have to use the change of base formula. Log 8 divided log 2 comes up to 3. Okay, so then I can plot these points. So 1 and 0 is a point. 2 and 1 is a point. 4 and 2 is a point. 8 and 3 is another point. So that'd be, I don't know, that's sort of over here somewhere. Anyway, it looks like the graph. I wonder if I could get some information around here, like 0.5. If x was 0.5, what would y be? Try that on your calculator. So log base 2 of 0.5. So you'd have to go log 0.5 divided log 2. I think it gives you -1. So I'm at 0.5, I'm at -1. And you'll see that the graph of this one, it just keeps going closer and closer to that x-axis, but never touches. So this graph here should be the reflect of that. So if I were to reflect that, it probably looks something like that. And we can try. Let's try some points. So now I have y equals 2 to the x. That's what I want to do. So let's plug in some numbers. Let's plug in, for x, let's plug in a 0. 2 to the 0 is 1. Let's plug in a 1. 2 to the 1 is 2. Let's plug in a 2, that'd be 4. Plug in a 3, that'd be an 8. Notice that the numbers are similar. They're just backwards, inverses of each other. That's sort of what that symbol there means. So 0, 1, I've got a point. 1 and 2, I've got a point. 2 and 4, I've got another point. 3 and 8 is another point that's up there somewhere. So see how it's sort of reflecting this over that as being the mirror. So the graph is going to look something like that, and this is going to get closer to that line and never touch. Okay, so that's the idea behind a log and exponential graph, is that they're inverses of each other across that line. So graphically speaking, they're inverses, that's a mirror. If you look at the data, you just take a look at the numbers on this side and the numbers at this side, and they're just flipped over. Okay, one last question. This one is a transformation type question. So they want you to know what this one looks like in relative to this one. Well, knowing all of those transformation things, like you have a f of bx minus c plus d, I see that this 2 is in a C spot right there. And so it must be moved 2. Since this is plus, it's backward to what you'd think. So this one is moving left by 2 units. So if I graph this log base 5 of x, and it's going to have the the same kind of look as most of them. Sorry, I got a cold. Log base 5 of x. Let's try an x and a y value. If I put a 1 in there for x, that'd be 0. And again, try that on your calculator. Log base 5 of 1. You go log 1 divide 5, you come up with 0. Let's put a 5 in there. So log base 5 of 5 is 1. There's just a couple points we can use. So 1 and 0, got it. 5 and 1, got it. So this graph is going to look, it's quite a bit squished, more squished than the other one, but it's going to look something, I went too high. I'll maybe start here. And then it gets closer to that line and never touches. It has to have that sort of log look to it. I just can't make it look good with this here. Now, this graph here is this same graph, but it's moved over 2 to the left. So if I just take this line that I drew, that's a pretty lame one, and if I move it over 2 to the left, there we go. So this is where it was at, and I'm going to move it over 2 to the left. So 1, 2, about there. So this graph is 2 left of what that graph is. Okay, hopefully that helps you with some of those questions.